In this problem, we have a pair of pliers, and they're being used to grip the tube at point B, and we have a pair of forces acting on these handles in order to apply forces here at point B. And we need to determine the internal shear force and moment at the point C. We're going to assume that the jaws of the pliers exert only normal forces on the tube. What it means is that if you draw the free body diagram of the tube alone, then the forces exerted by the pliers onto the tube are going to be in this direction. And that also means that because of action and reaction, here the force exerted by the tube to the upper half, or this half of the plier, is in this direction. And because of action and reaction, the forces exerted from the tube to the plier here is in this direction. So we cannot solve for anything if we treat this entire pair of pliers as one system, because as you can see, these two forces, they are opposite and equal in magnitude, same line of action, they cancel each other out. And these two forces, they cancel each other out as well. Therefore, we have to separate this pair of pliers into two halves and choose one half in order to solve for this force right here. So if we draw the free body diagram of only, I'm not doing a very good job, but this is the idea, okay, of only one half here. As you can see, the forces here, force here is going to be 20 pounds up, and then over here we will have this force exerted from the tube to this half of the plier. And also at point A is a pin, we would also have AX and AY reactions. So let's call this force F. So because we do not need to solve for AX or AY, we can summarize the moment about point A in order to solve for our F. So about point A, this 20-pound force has a moment arm of 10 inch, this much right here. And this force, our unknown force F right here, has a moment arm of 0.5 plus 1, 1.5 inch. Therefore, resultant moment about point A equals to negative 20 times 10, because this 20-pound force creates clockwise rotation about point A, plus the force multiplied by its moment arm, which is 1.5 inch, equals to 0. So from there, we can solve for the force F to be 133 pounds. So this is the force exerted by each half of the plier onto the tube, but also in magnitude equals to the force exerted by the tube to the plier. So now with that said, we can again use only this half of the plier and section it here at point C. We're going to section it this way so that it's in this direction, so that this direction is parallel to the force here. And then we're going to choose only this portion to do our internal reaction analysis. So now we're going to draw the free body diagram of only that segment. And let me do my best to sketch it out. It looks like this. And point C is right here. So here we have the solved force we have already solved for, that is 133 pounds. And normal force is always normal to the cross section. So this is the normal force NC. Shear force is always tangent to the cross section. So this is the shear force VC. And here we also have the bending moment MC. So if we choose the coordinate system to be X in this direction, Y in this direction for convenience, Then now we have completed the free body diagram. We can now set up our 3 equations to solve for the unknowns. So resultant force along the x direction, x is in this direction, and that equals to negative NC, which is simply 0. So NC, the normal force, is 0. Resultant force along the y direction, remember y is in this direction, and that equals to VC plus 133 pound equals to 0. And lastly, we summarize the moment about point C. Still counterclockwise is positive. VC has no moment about point C. Therefore, we have our unknown bending moment MC clockwise, therefore it's negative, plus the moment caused by this 133 pound force about point C with a moment arm of only 1 inch, this right here, and that equals to 133 times 1 inch, and that equals to 0. So from here we can solve for VC to be negative 133 pound, MC to be positive 133 pound inch. So if you want to convert that into pound foot, you divide this number by 12, and that's 11.1 pound foot. So let's solve this problem.